When I talk about solid figures, this time we're talking about volume. Okay? Volume of a solid figure, or 3D figure, is basically the area inside, or the space inside of each one of these figures. So think about like you have these types of containers and you want to fill them all with sand. How much can it hold? Okay, that's what volume is. Some of your volume formulas are given to you in your. Which one of your volume formulas are in your reference book? Which ones? Pyramid, cone, sphere, no cylinder?
Yeah, volume cylinder.
Cylinder? What about prism?
Cuboid.
Yeah, right below cylinder.
Okay, so you have cuboid in there. Now, cuboid is a type of prism, yes. And let's see, the formula is literally for like a rectangular prism. Okay, you can use that length times width times height, identify what the base is. But when you have a prism that's not a rectangular prism or a cuboid, which is, kind of like what this room is, the room that we're in, then you're going to need to use a different type of formula, which is just big B times H, where the big B stands for the area of the base. So whatever your base is, whether it's a triangle, or in this case, it's a, no, what's the shape? A hexagon. You have to find the area of that, and then, of course, multiply it by the, what's H stand for? Height. Okay?
The area of the base.
Hmm?
How do you get the area of the base? Oh, I got you.
Yeah, so we're going to do that. We're going to find the area of the base here. All right, and what's nice about this, a lot, and IB problems do tend to do this, is that they're going to kind of walk you through all the steps to get you to the point where you do find the area of that base, and then, of course, use it to find the volume of the prism. Okay, so we're going to get right into it with these examples. We have a diagram shows a prism with A, B, C, D, E, F, a regular hexagon. Geometry word, regular. If a polygon is regular, what does that mean?
It's not like a funny shape.
All sides are congruent and
It's defined, like it's closed.
oh yes, definitely that makes the polygon, yes, has to be closed. But if all sides are congruent, then that means all angles are congruent as well. That's what it means to be regular. Okay, so this is a regular hexagon or a regular pentagon or a regular anything. That means that all the sides and all the angles are congruent. Okay, so each side of the hexagon is 5. So that means that all those sides, A, B, A, F, E, F, so on and so forth, they're all 5. And the height of the prism is 13.5, as we can see in this picture. It says, what is the size of angle COB? We're looking for this angle right here. Okay? Now, in a hexagon, in a regular hexagon, all of the angles are equal and all the sides are equal, which means we can figure out what angle COB is knowing the fact that all the angles are equal. Geometry throwback. Okay? I had a question.
So the volume of that is the big times height?
Yeah, so we're going to find the area of the hexagon, which we're actually going to end up doing in part C,
So
and then we'll multiply it by the height, which will be part D.
So it works for all prisms?
It works for all prisms. Yeah. Including the cuboid. So, geometry throwback. How do you find the angles, like the measure of all the angles in a polygon? No, not divided by how many sides it has. That's how you'll find out the measure of just one of those angles. But you need to know all the angles before you can do that. That's going to be my next question after that. Have y'all taken the SAT or the ACT yet? You know that question is always on the SAT and ACT. Okay, let's do it a different way. What angle COB forms a what with side CB? A what? A triangle. Okay? So if I have a hexagon, can I create triangles from O to all the other vertices? Okay. many triangles have I created? There are 6 triangles. And how many degrees are in a triangle?
180.
So couldn't I just do 6 times 180 to find that? What's 6 times 180? Okay, what is it?
1,000.
This is what I wanted to go with it. No. Actually, sorry, let's scratch that. That's not where I wanted to go with it. I went the wrong way. But actually, this is actually going to help us answer A, and then I'll go back and address the other question. So, if this creates 6 triangles, right in here, I can form a circle. How many degrees are in a circle? 360. And so if angle COB is a part of that circle, you divide it by 6. So what's 360 divided by 6? Sorry, I meant to go this way. And that is the size of angle COB. And every single one of those triangles is the same. Now, to address that actual question that I asked you before, how do you find the angles in all the triangles or in the polygon? Sorry, you should start at 1 and draw triangles connecting all the vertices, or lines connecting all the vertices. How many triangles do you see? 4. And there's 180 degrees in each triangle. What's 4 times 180? That is the sum of all the angles in a hexagon. Now the formula to do that. How many sides was the hexagon? 6. So how can we get 4 from 6? What do we do? If I have 6 sides, how can I get to 4 from 6? No, don't overthink this. If I have 6 sides, but I write a 4 instead because I can create 4 triangles, how can I go from 6 to 4? Thank you. I said don't overthink it. Just subtract 2, right? 6, what does 6 represent? Number of sides there are. That's the formula to find the sum of all the angles in a polygon. And it works for every single type of polygon there is. So if I have a pentagon, if I follow that formula, that would be 5 minus 2 times 180. What's 5 minus 2 times 180? $540. So that means the sum of all the angles would add up to be 540. And if I create, again, the triangles going from one vertex to all the other vertices, how many triangles was that? 3. 3 times 180, 540. Okay? Remember this formula. It's on the SAT, it's on the ACT. Okay? Will you need it for this class? It's possible it could come up. Okay? So that is good to know. Alright? Going back, surface area and, going back to volume. So we found the measure of that angle. We know that this angle up here is 60 degrees. Now we have to find the area of the triangle COB. What kind of triangle is COB? Say again. It's isosceles. Okay. What's its length? What's the length of CO and DO? 5. You said 5? Why is it 5?
It's equilateral.
Each side of the hexagon is
Equilateral. In a hexagon, when you create, in a regular hexagon, the triangles inside the hexagon, they're all equilateral triangles. It only works for a hexagon. In a pentagon, it won't be that way. Okay, but in a hexagon, all the sides are equal. And that's something from geometry. So knowing that, and knowing that this angle is 60 degrees, how can I find the area of this triangle? Say again. Okay. What's the height of this triangle? We don't know it. So we would have to technically do like some trig to find it. Isn't there another formula that we know though to find the area of the triangle?
1/2 times B times C and sine of A.
1/2 B times C sine of A. Or technically 1/2 two sides and the included angle. So 1/2 5 times 5 times the sine of 60. That's how we find the area of the triangle. What is it?
10.8.
It is an 8.
Yeah, 10.825.
It's a long number.
So 3 significant figures.
10.8.
2.8.
10.8.
Oh, 10.
10.8.
That's what I was saying, 7.8. And let's not forget our units, so centimeters squared. Now we have to find the area of the regular hexagon. How can I do that? Yep, because I have all the same triangles, and there are 6 of them. So I can just multiply the area of triangle COB by 6, preferably not the rounded answer. 65? Use the non-rounded decimal, correct? Okay. Now we can find the volume of the prism. Volume of the prism is nothing but the area of the base times the height. Well, we know the area of the base, don't we? So all we have to do is take that answer, so the answer from part C, and do what? Multiply by 13.5. The non-rounded answer, preferably. What do you get?
876.85.
And volume, the units are what? Cubed. Volume is cubed, area is squared. So there you go. Questions? So this will apply to any prism, that formula. However, you do have a cuboid in your reference book. Questions? Pyramid, you guys said the volume formula was in the reference booklet, right? Right, pyramid? What is it? Area of the base? Okay, I'm about to say like it was more right. Do they use A or B in that formula? They use A. So capital A and then H, where A represents the area of the base. And H, of course, represents the height. A pyramid's volume is always a third of its respective prism. Okay? So if you can remember that, then you'll always have the volume for a prism. Okay? Just right there. There we go. The diagram shows a right pyramid with a regular hexagonal base. So we're back to the regular hexagon. The volume of the prism is 84 centimeters cubed. They give us the volume. So volume is 84 centimeters cubed and the height is 7. O is at the center of the base. We need to calculate the area of the base. Okay? So, since we know volume already is 84, we can set 84 equal to the equation for volume. Can we not? So that's going to be 1/3 A times H. But don't we have H? So we can plug that in, and then we can solve to find the area of the base, capital A. Okay? Go ahead and do that. What you get?
36.
And it's going to be 36 centimeters squared. Okay? You can do it many ways. You can multiply both sides by 3, divide by 7. Multiply both sides by 3 over 7. By the way. Anybody not get 36? Part B. Now it says find the area of triangle AOB. How can I do that?
Divide the area by 6.
And we know that we can do this because in a hexagon, a regular hexagon, all of those triangles that from that last drawing, we know they're all equal. So then what's that going to be? 6 centimeters squared. Okay? It's asking what is the size of angle AOB? AOB is this angle right in there.
60 degrees.
How do you know?
Because 360 divided by 6.
That's right, 360 divided by 6. So basically what we're doing in this particular problem is we're working backwards. Okay? Working backwards. So how do you find the length of AB? How do you find the length of AB? I know that all three of these sides are the same. It's an equilateral triangle because it's a regular hexagon. Okay? But in order for me to do Pythagorean theorem, law of sines, cosine, area of the triangle, I'm going to need to know one of those lengths. But right now, I know none of those lengths. The only thing I know is that they're all the same.
Whenever I set up, like I was talking about the 1/2, or area equals 1/2 base height, I put in for the area 6, and then 1/2 b, and then for height 7, and then I just divided 1/2 times 7 from 6.
See, the thing is, 7 represents the height of the pyramid, not the height of the triangle. Like, they're not the same.
Once you found your base, because the base for OB,
AB, right. But the thing is, you're trying to use 7. 7 is the height of the pyramid, not the height of the triangle. So we can't, like, those 7s are not the same. Like, those H's are not the same. The H here is the height of the pyramid, but the H in 1/2 base times height is the height of the triangle, and those are not the same.
We use the area of the triangle since we have the sine 60,
Right. Okay.
And then we don't have a sine. Couldn't you, we have the area of the triangle?
We have the area of the triangle. We have the
Plug
angle.
that in and then divide by A and B and then divide by 2.
That's divided by 2. I think I see where you're going. When you don't know something in math, what do you usually use?
Variable.
A variable. Give me a variable. X. Okay? All of these are the same. Now, if I take what Jan was saying and use the formula of 1/2 AB sine C, which is the area of a triangle, any triangle, I know the area is 6. I know the angle is 60. And what would my two sides be?
2x.
Not 2x.
X squared.
X squared, because it technically would be x times x.
Why did they just root it?
And then you square root it, not divide by 2. Whoever says to divide by 2 part. Okay? So, right now you have
6 equals half times x squared sine 60.
So I'm going to multiply both sides by 2 to get rid of the 1/2. This becomes x squared sine 60. Then I can divide both sides by the sine of 60. And then to find x, which is OB, which is OA, which is also AB, I just have to square root. And this only works because it's a hexagon and all those side lengths in those triangles are equal. It's an equilateral triangle inside of a regular hexagon. What's that number?
3.72.
Moving on to cylinder. An example is cylinder. Okay? You have a cylindrical water tank, has a height of 3 centimeters and a base radius of 1.2 meters. We have to calculate the volume of the tank in meters cubed. Now, real quick, what's the volume for a cylinder? Is it in there?
Its volume equals pi r squared.
Pi r squared height. What page are you on?
2.
Page 2. So go to page 2. Was that prior knowledge? Was that actually in geometry and trigonometry?
Prior knowledge.
It's in prior knowledge. That's why. Okay, but it's in there. So volume of the cylinder is pi r squared h, and we are looking for the volume. So this one's pretty simple, right? Don't we have all of our information? Yes, we do. So we know our radius is 1.2, so we're going to square that. We're going to multiply by the height, which is 3, and then multiply by pi. So let's go ahead and do that. What did you get? 13.6? Yes? Cubes. Because we are talking about volume. Now it says give your answer to part A in dm cubed. What is dm cubed? It is decimeters. It is the d that's to the right, not the d to the left. That one is deca, the one that's to the left, and it would have been DAM. Okay? So, decimeters is how many to the
Right.
to the right?
1.
It's 1, right? King Henry died while drinking chocolate milk. So meters is here, so decimeters will move over 1. Now, do not make this mistake of taking the volume in meters squared and just moving the decimal place over 1. Don't do that. Okay? That is not the correct answer. If you are going to use the volume answer to convert to decimeters squared, you're going to need to move it over 3 times. Not once, but 3 times. Because volume is cubed. So you triple the number of times that you move it over. If that went over your head, then why not go back to the original measurements and convert those to decimeters and then find the volume again. Okay? If I convert 3 meters to decimeters, what does it become? No, like this. No, like the 3. It will become 30. So this will be 30 decimeters. 1.2 would turn into 12 decimeters. So then I could do the volume again with those numbers. 12 squared times 30. What's your answer?
But if it's rounded, it would be 72.
3 significant figures.
136.
1, 3,
136, 0.
0, 0. And that's what I was saying. You don't move it over 1 time, you move it over 3 times. And that's what you get if you actually convert the original units to decimeters. Okay? When you are converting and you have to use area or volume, it's never just 1 over or 2 over. It's doubled if it's area or tripled if it's volume. If you don't want to if you don't want to use the volume formulas to potentially make the mistake, then go back and convert the original units to what they should be. It prevents that error. Okay? Questions on that? Hence, find in liters the capacity of the tank. Now, this goes back to science and prior knowledge when it comes to math. Capacity in liters. What's the conversion? What is the conversion? Who knows it? So 1 liter equals 1,000 centimeters cubed. So we need to figure out what is the volume, probably in centimeters cubed, so then that way we can make our conversion. Okay? So, which way you want to go? Do you want to take the meters cubed or the decimeters cubed to figure out what it is in centimeters cubed?
Meters.
Okay. Like you want to go back to the original units, or you want to try to move it over?
Like, they would just go from 13.6 meters to centimeters?
And how do I do that? Do I move it over twice?
No. No. 6 times.
6 times. If you're going to move it from the original volume, then you're going to have to, remember, not twice, you have to triple everything for volume. If you want to prevent that, you go back up to the original measurements and convert those to centimeters.
So can you just multiply by 10 like, to the 6th power, instead of doing, like, times 6, like, 10 times itself 6 times?
So, the volume of this is going to be 136, and how many zeros?
5. And then you divide it by 1,000.
And then you divide it by 1,000.
So it's 13,600
13,000.
liters.
Questions? Remember that? It's like that prior knowledge.
No, that's the
Forever. All right. Let's finish up the last two. Okay, we're gonna do a cone and then sphere. All right. Gene wants to sell lemonade in a cone-shaped paper cups. Each cup has a diameter of 4 centimeters and a height of 8 centimeters. If the diameter is 4, what is the radius? 2. She wants to make enough lemonade for 50 cups. How much lemonade does Jean need to make? Round your answer to the nearest 10. So, if she's putting her lemonade into these paper cups, we probably want to figure out how much one paper cup can hold. Correct? So, that means we need to find the volume. Volume for a cone is 1/3 of a cylinder. 1/3 pi r squared h. So 1/3 pi r squared and h. Let's figure that out. So we have 33.5 centimeters cubed. This equals 1 cup. But she wants to make how many? So we need to multiply that by 50. So go ahead and take that non-rounded answer and multiply it by 50. No, the non-rounded. How much?
1,680.
Just read the numbers left to right.
167.
So 1675, ... So about, yep. Oh, we have to round to the nearest 10, sorry. I'm so used to doing it. When it says it's something different, it always throws me off. So 1675.5. That was the easy one. And the capacity blew y'all mind for a little bit. Last one, sphere. The diameter of a sphere is 8.8. So if the diameter is 8.8, the radius is 4.4. Have mercy. All right, what is the exact volume of the sphere? Exact. This word, exact, means what to you? Don't round. Okay? So I can't round, but that also doesn't mean write out every single decimal that you see in the calculator screen. Exact, you don't want to multiply the pi through. Leave it without the pi. You remember how I was writing like 30 pi the other day when we were doing surface area? That's what that means. Those were the exact answers. You just do all the other numbers, leave pi out, and then attach your units. That's what it means to be exact. So when it says what's the approximate value, what's the exact volume of the sphere? Volume for a sphere is what formula? Then when you plug everything in, you're basically just going to multiply the 4/3 by 4.4 cubed only in your calculator to figure out what that number is. Did you get a decimal? Can you convert it back to a fraction? Is it a fraction? No, but can you convert it to a fraction? Okay, go ahead and do that. How do you convert back to a fraction?
Alpha Y.
No, not alpha y. So y'all got this decimal, right? I never showed you guys. Didn't we have calculator like 101 one day?
Yeah, you go to math and then you put the fraction.
Go to math, and then you go to fraction, enter, and it converts it to a fraction. I didn't do that in calculator 101 with y'all.
Yeah.
They usually that's usually the first thing I always show. You learned that from me?
Yeah.
Thank you. I think that confirmation was. Oh, I don't use that from you. No idea.
Cube the number.
I cubed the radius.
But how do
Alright,
you
maybe
say
that.
Well, you just put
a button?
Yeah.
Okay.
So then that. I don't give me no reassurance. There you go. Math. And then just press enter twice. I definitely didn't. No, I definitely didn't show y'all this because, it doesn't make any sense that y'all don't know this. I was about to say, how in the world? I always show that
You
one.
showed us how to get pi.
Yeah,
You showed us how to.
You showed us how to get the fraction. I learned it here.
Okay.
I
That's
remember
one of my first things. It's always the first thing I do because it's like the best thing ever.
I think we forgot it because we haven't used it yet.
Your computers.
Yeah, your computer's about to die.
Your computer's low.
Yeah, all right. This is my last problem anyway. All right, so we have let's see, 42592 all over
375.
375 pi meters cubed. That is your exact volume. No rounded decimals. Fractions are always more exact. And then, of course, with the pi, we just know that if we wanted to get an approximate rounded value, which is asking us to do, then we just actually type all that into our calculator.
So if you wrote it, like your answer says, if you wrote it as the decimal and stopped it after like 2 places after the decimal point and pi, would it be wrong?
It would be wrong. Because that decimal, if it was a decimal or a fraction that ended, then it would be correct. But that decimal did not end. So then it would be incorrect. So let's find the approximate value. That actually means multiply it all the way through. Multiply everything through. Okay? Multiply it through and give me the approximate value rounded to the 10th place. All right, what's the decimal to the nearest 10th place?
356.8.
So that'd be 8
Yeah, buddy.
meters cubed. That is the approximate. Exact, top box, approximate, bottom box. That's how you find volume. of all your different shapes. Again, your formulas are in your reference booklet, except for volume of a prism. But remember, since you do have pyramid, a prism is just the area of the base times the height. Okay? Because a pyramid is 1/3 of a prism. Any questions?